For this exercise, we will be drawing a conclusion about the square wave signal based on its Fourier series representation. So we will start with average value of that signal. As we can see, there is no A0 value in the formula for the Fourier series representation of our signal. That means that the average value is equal 0. There is no vertical shift. Secondly, we will be looking at the peak-to-peak value. Based on our graph of the square wave signal on the right side of the screen, the peak-to-peak value will be equal to V. For V over pi is equal 16 over pi. Therefore, for V is equal 16. V is equal 16 divided by 4, which is 4. 2 times V is 2 times 4. It is equal 8. Therefore, our peak-to-peak value is equal 8. Frequency of the signal. Our question doesn't precise if we are asked about angular frequency or frequency. In case of angular frequency, we know that this is equal omega, which is equal 100 pi. And the frequency can be calculated based on that. Frequency is equal omega over 2 pi. In our case, it's 100 pi over 2 pi, which is 100 over 2, which is 50. Frequency is given in hertz, so this is 50 hertz. When it comes to period, we have to calculate it by t being equal the inverse of our frequency. So t is equal 1 over 50 hertz. Hertz is 1 per second. That means that the value of t will be given in seconds. And this is 1 over 50. It's equal 0.02 seconds. So we calculated our period. Our next task is provide the expression for V of t as a square wave signal. The general formula for that will be that is equal V when t is between 0 and half of the period, and minus V when t is between minus half of the period and the period. So in our case, V of t is equal, the value of b is equal 4. So it's 4 or minus 4. It's 4 when the t belongs to the interval from 0 to t over 2, which is 0.01, and minus 4 when our signal is from 0.01 to 0.02. We used information about the period of our function and information about the peak-to-peak value of our function to figure out how the expression would look like. Now we will be sketching the waveform of our signal. To do that, firstly we need to mark on the y-axis what is its maximum and minimum value. Maximum value is equal 4, minimum value is equal minus 4. We need to mark period on the y-axis. We will mark it as 0.02 and the half of the period, that is 0.01 in the middle. Of course, we can mark as well additional points. Our signal takes value 4 from 0 to 0.1, and then the value of minus 4 from 0.0.1 to 0.0.2, and this pattern is repeated every 0.0.2, which is the period of the function. 0.02 is the value t, 0.04 is the value 2t, and 0.06 is the value 3t. We will sketch line spectrum of given signal. X-axis would represent multiples of angular frequencies of the signal. So it will be 100 pi, 200 pi, 300 pi, 400 pi, 500 pi, and 600 pi. And y-axis will represent amplitude of each harmonics. So the harmonic 1 has amplitude 16 over pi. Let's mark it here. Given signal has only odds harmonic, so the next one will be for the angular frequency 300 pi, and it will be 1/3 of the initial frequency. So this is 16 over 3 pi. 1/5 of the frequency for first harmonic. We can mark it somewhere here. We use expression for V and Parseval theorem to calculate signal energy using direct integration. E is equal 1 over period, in our case is 0.02, integral. Now, because our function is pairwise function, we will split our integral into two. So from 0 to half of the period, which is 0.01, 4 square dt, plus integral from 0.01 to 0.02 minus 4 square dt. That is equal 1 over 0.02 is equal 15. Integral from 0 to 0.01, 16 dt, plus integral from 0.01 to 0.02, again 16 dt. That is equal 50. 16t from 0 to 0.01 plus 16t from 0.01 to 0.02, and that is equal 50. 16 times 0.01 minus 0 plus 16, 0.02 minus 0.01, and that is equal 16. So total energy of our signal is equal 16. Now we will calculate signal energy in the first three harmonics based on the Fourier representation of given signal. We calculate the value of energy for first three harmonics, so it's 1 over 2, sum from n equal 1 to 3. A0 in our signal is equal 0, as well as all ANs, so we will be only summing BN squares. It's 1 over 2. Coefficient of our second harmonic is equal 0, so it will be B1 square plus E3 square. That is equal 1 over 2, 16 over pi square plus 1 over 3 times 16 over pi square, and that is equal 14.41. Now we have to calculate what percentage of total energy is in the first three harmonics. So we will take 1441 divided by 16, that was the total energy, multiplied by 100%, and that gives us answer 90%.